Hi, Lakshmi.
Hi.
Let me put on a... Okay. Thank you for being on time.
I actually did something stupid. I came in and I
because I couldn't really apply a lot of the concepts of ecosystems and ecology and complex systems that I had learned as they applied to the biosphere to the way that humans would be making decisions. And so I continued my studies, and this was in Argentina. I came to the United States to study urban planning as the interface with decision making, but also complex systems modeling as well. And I've used this combination of backgrounds and skills to focus on the modeling of coupled human natural systems to try to inform with that modeling approach planning and policy for sustainability and resilience. And this is what I'm going to show is like a part of my work that focused on this interdisciplinary research to create participatory modeling for the kinds of collaborative decision making that is necessary in to address complex problems. I'm not sure why it's not going forward. Let me see. Oops, there we go. Okay. So one of the things so with my former mentor and colleague Scott Campbell, we've published a few pieces of work on complex systems and wicked problems and the parallel between the two. And we were thinking about how complex systems reasoning is used in planning, and definitely in planning and policy, we acknowledge the complexity of the world we live in. But a lot of the time, this acknowledgement, it's kind of like an external or in a way superficial kind of understanding of complexity, an acknowledgement that it's there, but not necessarily, an internal understanding of how it works. And a lot of my work has been on this stage two, which is really using complex systems tools to understand these complex systems and using that to reason and analyze situations to then be able to inform policy. But still there's an additional stage in this, which is incorporating these analytical techniques, which we don't necessarily do it in a widespread form in planning and policy, to really incorporate it into the planning and the plan making activity itself, and really moving from the analytical observation to practice and to implementation. And that's where participatory modeling comes in. And the problem that we have in moving through these three phases is probably because we come from a model of work where analysis and modeling occurs separately from stakeholder and policymaking deliberative spaces. And this is, supposed to be a neutral or unbiased activity, the modeling part of it, which is focused on a prediction and accuracy, so that, to respond to the demands of policymakers and decision makers in terms of like, okay, we want to know what's going to happen to fulfill our goals and aspirations. And these goals and aspirations, which are discussed in the policy world, tend to often focus on growth, in one form or another. And so the models then become, for the demand for accuracy, become these complicated black boxes that are, used to predict future projections to respond to the goals that, again, are established elsewhere in the system. And this imposes a rigidity in the decision-making process where there's little opportunity for adaptation and innovation, and to even see the role that our goals have in promoting the problems or the trajectories that we're in right now that we are having a difficulty moving away from. We cannot understand how the goals are driving the system and are part of the problem unless we can understand the inner workings of the models that represent these systems. But the way that that the modeling happens outside of the policymaking world just does not allow for that kind of conversation. And so what I've been trying to advocate for a while, and I think that there's definitely an increased momentum for this, as evidence of the fact that this talk exists, is that the integration of these two worlds into one, where we're all stakeholders, so scientists, researchers, policymakers, and constituents, we're all in it together, where we're all working with complexity and the messiness of this decision-making world. And this is a way to integrate different forms of knowledge. The information, assumptions, and goals become visible to everybody to discuss and negotiate. And it supports a joint learning process of innovation and adaptation and the development of empathy as well as we integrate these two worlds into this ongoing and iterative activity. And ultimately, this activity needs to, inspire change. So co-creation of knowledge, but also that inspires change. But there are some challenges to doing this. And of course, as you communicate across different expertise, the spatial thinking and computer modeling can be still hard for a lot of people, even with our era of gadgets. But then there's also issues around modeling itself, like the, confirmatory bias and the fact that, if models produce results that are dissonant to with what we believe in, then we tend to discard them. And if they actually align with what we believe in, then we accept them wholeheartedly and without examining them or questioning them much. And finally, the other one that is very relevant to planning and policy is that we tend to focus on consensus building. And the only way that we can all agree, oftentimes, especially in contentious situations, is by generalizing our recommendations to the point of making them meaningless. So from saying like, okay, we've got to build green infrastructure here, here, and here, and this is how much it's going to cost, and this is what it's going to do, to, well, we just have to be green or be sustainable or promote sustainable development, and what does that mean? So this really led me to going from the policy world to the modeling world, or the focus on modeling, to really thinking of inserting modeling within a broader social context of collaborative learning and planning. So my research has been about looking at how can complex systems modeling help us learn, and how does this learning lead to better planning, deliberation, and decision making? Because one thing is to learn, but a very different thing is to implement what we're learning. And so I'm going to share with you just very briefly the foundation in modeling, and then how that went into participatory modeling around aspects of green infrastructure planning. So many years ago, we got funding from the Illinois Environmental Protection Agency to come up with some work to support the regulation of green infrastructure, or incorporating green infrastructure as a way to do stormwater management in Illinois. And of course, again, for the skeptical in me was like, okay, green infrastructure is great, but we don't really understand how it works at a landscape level. So how much do we need to put for it to be effective? Like, where should we put it, especially as we're thinking of urban neighborhoods? And so we developed a model to do this, and there's a publication that I'm happy to share if anybody's interested on, that model. That model is also available if people are interested. It's a landscape green infrastructure design model, and it's a spatially explicit, computationally based model that essentially simulates how water flows through an urban neighborhood. Again, I don't want to delve into the details of this. I can do that in the Q&A if people are interested, because that's not entirely the focus of the talk today. But it's a process-based, so it does represent in space like all of these different activities and processes that generate rain and flooding in an urban area, including, of course, rain infiltration, uptake by sewers, evaporation, surface flow, etc. And so with a model like this, we can explore questions of, okay, given different kinds of storms, how much green infrastructure is needed in order to reduce flooding or eliminate flooding altogether. And so for smaller storms like we have on the left, the flood, you would just need about 10% to essentially get rid of flooding, and for the green infrastructure to overtake the job that the sewers are doing. In larger storms, clearly we need more. It's about 30% if we think of locating these green infrastructure randomly in a landscape, and it would take about 30% then to have that same effect. Now that's the question of like how much green infrastructure we think of random location, but we could also use these models to think of where or what kinds of spatial designs are more effective in terms of eliminating flooding in an urban area. So if you think of each one of these being a block, we can have like, a random, which is just baseline green infrastructure, all over the place. And here green infrastructure is a bioswale or vegetated garden or rain garden. What if we just put them, on curbs? What if we just put them away from curbs and within urban blocks? What if we cluster them upstream or downstream, or do a combination, what we call a hybrid or flow path kind of a design? And so we were able to very easily test these different scenarios and come up with some suggestions of things that might work better. And so what we discovered as a general pattern is that, those patterns that have a green infrastructure along the curbs are going to be more effective than those that do not have any curbside green infrastructure. Then those that are like clustered, like upstream and downstream, are actually very ineffective. It's better to scatter them through the landscape. So those were the kinds of insights that we were gaining from using this kind of modeling approach. And of course, when storms are great, are large and extreme, then you really need a lot more green infrastructure for the pattern to even matter. If there's not enough green infrastructure, the pattern doesn't matter. You're just going to get flooded because there's so much water. So from this modeling, we could derive some design principles that were useful for green infrastructure planning. So the fact that there are thresholds of amounts that are important for effectiveness, that there are some spatial layouts that are more effective than others, that there's an advantage of curb cuts simply because precisely they keep water in the roads, and the roads are designed in part to convey water to the sewer system. And by putting green infrastructure in the curbs, it slows down the flow of water so that actually it helps keep the peaks low. And there are advantages to also use curb cuts because there are fewer issues with installation in private property. And so it increases or enhances the ability of maintaining these sites. And then that, hybrid layouts are better or more resilient to larger storms. But if for whatever reason we can't do these layouts because there are limitations, well, in terms of for example, there's resistance, or there's just an opportunity to do green infrastructure in some places but not in others, random allocation is probably better than clustered. But again, just to show that these models can help us think about some of these questions that are important to design for sustainability, especially when these projects tend to be costly. And so it's better to, maybe run some simulations and get some information leading to the design. But that's not the only thing to consider. So to give you an illustration, is using the same model, we expanded that model, or we expanded those scenarios that I just shared with you to include other kinds of green infrastructure in addition to rain barrels. In addition to rain gardens. And here we have two scenarios of an urban neighborhood where each one of these is a block. It's an L-grid block. The green area is just, like having lawns and such. The dark grays are buildings. These are alleyways, and these are streets, and these circles are sewer intakes. And in this particular area, which is modeled after Blue Island, a section of Blue Island in the south side of Chicago, what we see is this area that is shaded darker. It's because it routinely floods with every small storm. It's a lower elevation, and that's why all the water kind of collects here. And so what we see is if we have rain barrels all over the place here, everywhere that we have a building cell, then we essentially have one result that I'm going to share now in a bit. And in this scenario, we have just a few scattered bioswales or rain gardens in the same neighborhood. So what happens here is that there's flood in both. In the baseline, without any green infrastructure, of course, we don't have any installation cost. And we have some damages, which are these red or pink squares here, just signify that the basement there of the building has been flooded. And so that amounts to $39,000 in damages for each storm. And 62% of the rain just flows downstream as runoff. When we have rain barrels, we spend $14,000 over the lifetime of the rain barrels. We barely make a dent in the reduction in damages per storm, and we don't make any difference on the outflow, the runoff going downstream. When we have bioswales, we spend much more money. Again, over the lifetime of a bioswale, they take a lot for construction and then for maintenance. But we do reduce the damages per storm quite a bit more. And we also reduce the runoff going downstream. So the question I always ask at this stage is, which scenario is better? And so, okay, so if I'm a public policy maker and I only have $15,000, what would I choose? If I'm a hydrologist and I think that we need to maximize infiltration, what would I choose? So probably if I'm a public official, I would choose the left. If I'm a hydrologist, I maybe would choose the right. But if I'm the resident living in this corner and I'm flooding no matter what, I might actually say the baseline. Why am I going to even spend money if I'm going to be flooded anyway, right? So it's not just about simulations. That alone is not going to give us answers to what is a solution for a particular community, because there are trade-offs. There are different costs and there are different benefits, and they affect different people at different times and in different places. So there are also like spatial and physical constraints to take into consideration. I cannot dig rain gardens everywhere. There are utilities underground. And so I have to, consider that into, factor it into the costs. And there's also, of course, diverse stakeholder interests, like depending on who I am and what hat I'm wearing, I might prefer different things. So it's not just about solution building, but it's also about the ability to generate compromise. And I'll get back to that word compromise at the end. But for that, we need to have an awareness of our preferences, like what we want, what other people want. And with that understanding, also be able to support then a joint evaluation of different kinds of scenarios and explore that solution space together. So we created this participatory modeling protocol that is centered around here, like the central piece, which is still the simulation, but it has other kinds of support as people come together around a table to jointly explore these different scenarios. So we created an app that we give a tablet to each participant, and they can essentially rank their priorities. So again, if I'm the hydrologist, I would rank, infiltration at the top. But if I'm the public official, I would rank investment cost at the top. And if I'm the resident, I would rank, damages at the top. And with that ranking, it would give different weights to the different variables that are the variables of interest in the simulation. People come together around a paper representation of that neighborhood that is being simulated, and they have like wooden tokens representing different kinds of green infrastructure, and together they create scenarios. And in this iPad has an application that takes a picture of the scenario, converts it into as an input to the simulation. It goes straight into the simulation and it runs in a couple of minutes, and it generates some results. This is just a different kind of display of a different project that we did. And then it runs in a couple of minutes and it produces results that then are downloaded to each iPad that each participant has. And each row here is a scenario that they've tried. And this bar that you see here is essentially a composite score that weights all the results based on each person's preference. So my bars are going to be different than anybody else's bars, as my weights or my preferences are different than other people's. And then here you see like the raw outputs from the simulation, also sorted out by what I prefer the most, but I can always scroll to the right and see the other ones as well. There's another viewer that allows me to see not just my results, but how my results stack against the results of other people, that bar that I was sharing, here. And so in this particular case, for example, the first case is all rain barrels. And of course, the policymakers, which is the second bar, loves it because it's a cheap scenario. But the pedestrian or the resident hates it because it really doesn't do much, as we saw, in terms of reducing damages and flooding. And so we can really evaluate not just how we assess each scenario, but how other people do, and understand where our differences lie, and what kinds of conversations we can have. So from this particular image, what we can say is that, well, you know what? These first two scenarios actually are not that great. Also because this one in particular is roof gardens. Roof gardens are very expensive. They don't really capture that much water. They can help me as a pedestrian, but definitely not the policymaker. So maybe we should just ignore these and focus on these other ones, because they do give us more happiness, more utility in a way than the other two. And here, what we can start discussing is like, okay, should we go for a scenario that it seems to be more equitable for both? Or should we go for another one that actually overall, if we add up all our happiness or satisfaction from it, it's greater, even though there's more disparity, but maybe I can compensate you for that disparity. Maybe as a resident, I gain so much out of this that I'm willing to pay more taxes to invest in this kind of solution. So that kind of information in a collaborative setting can go back to, you know, redesigning scenarios to just kind of like keep improving on the different plans, with an understanding of how water flows through the landscape and how our actions can divert the water to the places where we want it to be. But it can also make us aware of other people's preferences and values, and maybe even reshuffle ours. So we won an award for this work, the American Planning Association Academic Tech Innovator Award back in 2017. Here's Dean Massey, who has worked with me a lot for, you know, in developing a lot of these models. And Leila Lyons, also a colleague who's in the New York Hall of Science, and also learning scientist, and who's been my partner in crime all these years. So just wrapping up here, so things that we saw is that this kind of setup definitely supported the transparency and the visibility of assumptions and trade-offs, and enabling conversations of saying like, okay, this is great for you, but not for me. Okay, you know, we were able to reduce damage, but we went over budget by this amount. It also, facilitation here was key in helping them figure out how to conduct a systematic exploration, and they definitely engaged in that. This in the space of one workshop, it's a 1 2-hour workshop. They were able to study the solution space quite effectively and start using gesturing and mental modeling once they started to understand how water flowed through the landscape. So really using their hands, much like I do, but to show the flow of water through the landscape, saying, okay, if the water is coming this way, we should intercept it by putting green infrastructure here and here and here. And so they were able to already understand the dynamics of water flow in a flooding situation. And imagine if they start having different kinds of green infrastructure with different specifications and what that would do. So not needing the simulation anymore, if you will. But also gaining an understanding that green infrastructure cannot locally solve the problem, and that starting to think out of the box, thinking of moving people out of floodplains, imagining how to combine green and gray infrastructure, but also ultimately, and what is important, is the fact that they need to coordinate with other communities, as the impact upstream to downstream was important. So what are some of the main takeaways of this? First of all, that it involves the collaborative design process. This is not something that we just build in isolation. We build these models and these interfaces and the facilitation structures with stakeholders so that it makes sense to them and it's relevant to them. As I was saying, facilitation is really key and critical, and it's hard to do it on the fly. I've been there. So what our next iteration of this work is really focusing on creating the support structures and interfaces for the facilitator to synthesize the rich information that's coming from all of this deliberation and help move and advance the conversation forward. Then again, going back to the issue of like consensus or compromise, and compromise is sometimes, you know, has a negative connotation, but it's meant to be like, not just that we capitulate, but really what are the solutions that we can all live with? So it's not about optimization. It's not about, you know, the best solution, but really understanding the friction, understanding the differences and working with it rather than just assuming it away or diluting it. And so participatory modeling here is a point of entry to the problem, to other tools, to diverse interests, and to other problems. So once we learn how to do this around, say, a flooding issue, we can maybe engage with more sophisticated tools that simulate flooding and understand them better because we have this first exposure to these more simplified complex system simulations. Also, the understanding that there are other perspectives that might help, just knowing that there are other perspectives might help us just reach a place of move us away from gridlock and from just conflict and tension to trying to understand each other a little bit more and move forward with the differences. And then to other problems that are complex that may not be flooding, but that are still complex, and we have then the capacity to engage in those kinds of problems and inform them and inform policy around them. Why do this? Because we need to change established practices. The idea here is that we have these habits of thought and practice that distract us from seeing new opportunities. And so the visualization of process and value empowers us to see differences and address them rather than try to push back the conflict. So what I was trying to show here is how models, interfaces, and facilitation structures that support exploration and evolution of understanding and valuation can lead to innovation. And this innovation is in the relationship that we have with others and with the tools as prosthetics. The technical enhancement is not a technical fix. We cannot have a technical fix without social learning. And these has huge consequences, the ability to support novel solutions, but also the democratic process of working with difference rather than trying to eliminate it. So the planning tools and the social protocols around the use should support this, and this has to inform our design of these kinds of approaches, because this is where innovation happens. So I'm going to leave it here. I work with a lot of people, but I don't want to take up more time, and we can have more Q&A later.
Sure. Thank you, Dr. Zellner. Very interesting project and presentation. I would like to encourage participants and attendees to save your question for the Q&A part. Please feel free to post it in the Q&A part. We will save it. But at this moment, let me introduce our second speaker, who is not anyone except our very own Dr. Laxmi Ramasubramanian, who is the professor and chair in the Department of Urban and Regional Planning at San Jose State University. Dr. Ramasubramanian is the recipient of the 2019 Dale Scholar Prize in recognition of her commitment to preparing thoughtful and engaged planning practitioners and scholars who collaboratively work on critical technical and societal challenges while addressing issues related to diversity, equity, and inclusion through her leading role in multiple professional and academic committees, such as the Association of Collegiate Schools of Planning and in University Consortium for Geographic Information Science. She is the author of 2 books, Geographic Information Science and Public Participation, and Essential Methods for Planning Practitioners, Skills and Techniques for Data Analysis, Visualization, and Communication, which is co-authored by his research partner in this project as well as numerous peer-reviewed book chapters, journal articles, and conference proceedings. So without further ado, let me invite Dr. Ramasubramanian for her presentation.
Thank you, Hora, for that kind introduction. It's a pleasure to be here. Let me try to share my screen, and let's see if that gets us going. Do you see my screen?
Yes.
Excellent. All right. So it's great to follow Dr. Zellner. I've worked with Dr. Zellner as a colleague, friend for many years, but we've never been on the same panel together, and it's nice to follow you. I think I'm going to move us from thinking about green infrastructure to think about campus planning. And so as you can see, I'm going to present to you today a discussion and a mini case study of some work that my colleagues, Dr. Hillary Nixon from the Mineta Transportation Institute and Dr. Johan Albrecht from Hunter College, the work that 3 of us did in the summer and the fall, trying to help the conversation with senior leadership at SJSU as we were thinking about the process by which we return to campus. This is work ongoing, so it feels like, you know, talking about issues in real time. So the goals of our project. So this is situated in the context of COVID-19, of course. And last year, around this time in April, we had decided that all we would work online, as most universities did, but we were also thinking about the need to have some activities on campus. And so we're trying to figure out how could we activate the campus in fall 2020 and spring 21. And basically our goal as a team was trying to understand really which part of the campus is going to be heavily used when people come back. What times are is the campus going to be busy, and where are potential risks for infection? Now, to give away the takeaway here is that we relied on essentially one major data source, which is the student's schedule, the class schedule. We did not use any private information. We just used sort of student numbers. We used an agent-based modeling approach, and we focused on activities outside buildings, and I can talk more about indoor modeling at the end. So our audience, because this is really a project to think about how do you engage leadership in using evidence to support decision making, right? That's what Moira was talking about. And she was talking about a diverse set of audiences. Our audience in this project is campus leaders. Now, if you think about campus leaders, they are usually really good at the specialized work they do. For instance, folks who do admissions really know how admissions works. Folks who do residence life know how residence life works. But typically, the campus leaders don't necessarily know exactly what goes on in other parts of the campus that are not within their jurisdiction. However, they have a very rich experiential knowledge of campus, which is both good and bad from a planning perspective, because they rely a lot on that experiential knowledge to fill in the gaps rather than going to look at data or evidence. So there's a tendency to say, I know my campus, rather than saying, oh, let me see what the data tells me. And the point of view really matters, right? That they have a particular point of view and how they privilege certain activities. So student-facing activities, faculty-facing activities are privileged, whereas maybe staff activities are not. So the concerns that we were dealing with about a year ago, like I said, was really how do we plan for fall 20 and spring 21? And at that time, we did not have many data points. We had a couple of CDC recommendations, which are still in play, and that related to social distancing and the wearing of masks, and generally minimizing social interaction. So moving along, so the pre-COVID decision making on our campus tended to be actually quite good. It was bottom up. It was based on lots of data that people had, but they also conformed to established procedures and protocols. And there was no emergency situation that we had to deal with. And the decision-making drivers were efficiency, making use of resources like space effectively, because we didn't have the obligation of social distancing. And then it was also that when we were planning, people weren't really concerned so much about space-time conflicts. And I'll tell you why, because as I move on, I'll tell you why. So this all comes down to, if you know anything about campus planning in how our business works, the back end is driven by the academic calendar and the class schedule. So students who are here in the audience know how to use the schedule very well, and they know inherently the challenges of organizing their schedule to find the classes they need, but minimizing, say, commute time or minimizing a stress to them during their day. And there's a back end story to this as well. So the process is very highly evolved. And because uh, we've been doing this for a while uh, over time, and we've gotten the kinks worked out, except that those rules that we knew and we were familiar with, we were not able to apply during COVID times. And so during COVID times, what we had to deal with was the context kept changing very consistently. And, information and advice was given um, on a weekly basis. Things were changing. And as you can read from the slide, all of these challenges were being encountered. So this group, we decided to use agent-based modeling, and we selected a software which is called Gamma, is GIS agent-based modeling architecture. And we chose it primarily because it was free to use and it was accessible and something that we could experiment with to create a virtual campus model. And so in the interest of time, I'm going to sort of move a little faster here, but I can come back to it in the Q&A. So in the Gamma universe, we created agents and we created student agents. And this presentation is focused mainly on student behavior on campus. And if you think about it, students lead very complex lives. They have to come to class at a certain time. Obviously, our students tend to drive to campus. They park at garages near campus, and then they walk or take a shuttle. Some of them live on campus. And once on campus, they use the space very widely. So our campus is very modest in terms of being an urban campus. So they hang out, and the hanging out spots are the places that tend to get crowded. So what we decided to do in this case study is we made a bunch of assumptions, right? So we didn't look at their complex lives throughout the day. So we just focused on what we saw in the class schedule. We assumed that they followed the rules of behavior that were prescribed to them, and that if they lived on campus, they went back to their rooms. And if they took their class, they finished their class, they left campus, right? And so next we moved on to doing the work of establishing the campus model. And what you see here is our procedure. And so we ended up with three more than 3,000 individual student agents who are moving through our campus in fall 2020. Now, the actual number might have been more like 2,000, but it was because we only used schedule. We only knew how many people were registered to take a particular class. So if a student was registered to take 2 classes, then they ended up being counted twice. So here's a model, here's a map of our campus, and it probably doesn't make much sense to those of you who are not here in San Jose, but suffice it to say, it's a gridded campus. It's modest by campus, by university campus sizes. And this is what you'll see in the screenshots that I have of the model. So here you see the simulation beginning, and I'm not going to run a video for you, but I'm just going to do screenshots. The university administration had decided that only certain buildings would be activated in fall 2020, and they are recognized here in beige. If you see my screen to the right, you see Campus Village, which is where our students were residing. And so we knew where our students would come from. They would come from the campus village, they would come from the garages, or they would come from the different public points of entry to enter our campus. And so we ran the simulation, and as you know, if you run the simulation multiple times, then you get interesting data that we were using to draw our conclusions. So when we ran the first version of the schedule was proposed in July, and that planned for a heavier load of students on campus. And so you can see in the July schedule, when we modeled the data, we found that there was going to be quite a bit of overcrowding on these pathways that came from the garages and this bunching up that occurred. And I still remember when we presented it to our campus leaders, a senior leader said, "Oh, I can confirm your map with the anecdotal evidence that I see from my office window." So that was kind of an interesting way of like the campus leader believing our analysis because it conformed to their visual uh, assessment. But then if you look at the September actual schedule, then we realized that the university had made some decisions about closing garages, and the primary traffic is really coming from Campus Village. So here is another way when we were able to look at the schedule that was put forward by the campus leaders in July. And we found, you can see a little bit of overcrowding in this particular building on the center of campus. It's the music building. And that one got really full. And now once you think about it, it makes sense, right? So when our campus tried to bring back people in fall, we focused on bringing back activities that were hard to do online. And so we brought back activities like music, dance, performance, kinesiology. And so there's no surprise that the music building got crowded. And so based on that, our analysis, then some adjustments were made. And then the September schedule looks more reasonable. So moving right through this video link, I want to bring you back to the fact that everything is based on the schedule. So this is more or less public information to the campus. And then we were able to work with this. And for our team going forward, we think that this is useful because we can access both historical schedules and future schedules as we move forward. And to bring us to the concluding part. So here's some interesting data, right? So this is data of students on campus and looking, this is two different data sets here. So this is data, I believe it's midweek. So looking at the cadence of how student numbers go up on our campus based on the fall 2020 schedule. So you can see the peaks and valleys, but then the other data point that you want to notice is this line that talks about how the paths are used. And so you can look at that. It's not quite intuitive. So yeah, but you'd have to pay attention, right? So when students are in classes, then the path usage is lower. And then when students are not in classes, then they're walking about the campus. So I don't have time to talk about our partnership with SJSU Engineering, but let me summarize with our lessons learned. Our lessons learned are that we were able to use this tool to engage with our campus leaders because we had a common sort of place where we came together to understand the issue and to talk about it. We were all experiencing COVID and its impacts, of course, but we also understood the class schedule. And so we understood how it impacts us. And we were able to encourage our administration and they were already coming to this conclusion that they needed to think about extending the breaks between classes in order to minimize the crowding that happens between as people come in and people go out. So the very things that pre-COVID we cherish are how efficient we were in turning around a room from one class to another now needs to be reversed. We also gave them some guidance about the need for signage and which areas signage should be applied and where they should use movement flow sort of uh, standardized movement flows. And we are grateful and appreciative that our campus has actually acknowledged some of the recommendations we made in their planning for fall 21. So with that, I want to say that our ideas for future research are to model the movements of faculty, staff, and the public. We did do some work about public movements, but then they closed the campus to the public, so that was moot. Um, and we think that the potential of this work is really to think about engaging campus leaders beyond COVID. So thank you, and hopefully we have a few minutes for questions.
Well, thank you, Dr. Zellner and Dr. Ramasubramanian, for your wonderful presentations on participatory modeling. They were both so interesting, and we received one question from the audience, but I invite the audience to submit more questions in the Q&A. Our first question is, and this probably applies to both speakers, were there any challenges during the participatory process in which the participants had difficulty using the technologies or understanding the scope of the problem?
Yes. So that's part of the design process of like making sure that what we the kind of approach that we build and the interfaces that we build are more intuitive. So that's why we went from having people working around computers and laptops to having people working around a paper map that people are more comfortable with, and using different tokens that are intuitive and just take very little time to explain. And then yes, a brief overview of how to use the iPads, but it was overall fairly straightforward and easy to show them how to use these tools that people may be familiar already from other kinds of contexts. So that wasn't, but that was one of the main reasons why we moved away from the computers and more into that kind of more tangible kind of interfaces.
Wonderful. I had a question, and we just received one more question. Dr. Zellner, what are the difficulties of having the kind of participatory planning being applied for very large scale projects?
Yeah, so scaling up is a big issue. And one of the things that we're working on is precisely that question of how do we scale up this process? Because it works fine with a small workshop where if you have at most, 5, 10 people around the table, more than 10, it kind of becomes a little bit unwieldy, right? But a lot of these projects involve more people, affect more people. And so you want to be able to scale up. So given it also the pandemic, one of the things that we're exploring is a transition to an online platform to do this kind of work and keep the engagement going also in between whenever we can go back to in-person workshops. But assume that we will, and that we'll have those too, but like what happens in between or what happens beyond, like when people cannot make it to the workshops. So that's what we're working on developing an online approach as well.
Fantastic. Dr. Ramasubramanian, how is the provost and geographer Del Casino responding to your modeling?
We were grateful to have a geographer engaged with this work, right? Because one of the reasons I think he asked for this kind of analysis is because of his geographical training. And he also was able to understand our analysis and recommendations much more. He was attuned to it, and therefore it was helpful because he was there to support our arguments. And I think it was also really helpful because he was able to see the value of doing this work and continuing to do it, right? And so that is, we're really grateful and appreciative for that opportunity.
Excellent. I had a question about both of your work. Participatory modeling deals with future scenarios, but then after the decisions are made, are you finding that there's funding and support for doing little demonstration projects and that informing the model sort of after the fact, or how is that changing kind of the next steps after the decisions are made?
So in our case, we had some, I mean, we were excited to see that the product of some of these workshops led to actual decisions on the ground that, you know, people were happy with. Some of these have provided data that then can be used to feed back into the modeling and in a way form or provide a sort of validation for the model. And actual also, you know, excited that of course there was a match. There was a good alignment between the empirical data and then the modeling results. And so, you know, that's always really comforting and encouraging to see. But what was, I think, more exciting than that is the fact that people were better equipped to make some decisions that were not necessarily the ones that they thought they were going to take. And it really helped advance the decision making and the supervision of then the implementation moving forward.
That's nice to hear. We only have one more question. Will we be seeing your work in the campus master plan, and or how is it helping that effort?
One hopes that some of this, assuming that question is for me, that one hopes that some of this work will find its way into the campus master planning process that is currently unfolding. But it's more important, I think, for our team to use what we've learned and try to engage other stakeholders to bring people around the idea of looking at the data together, looking at the impacts, both the intentional and unintentional consequences of creating a schedule, which is essentially, you know, based on other considerations, right? And then looking at the consequences on the ground, and getting everybody to think about that would be helpful.
Excellent. That wraps up our Q&A. I'm going to hand it over to Professor Rick Koss for some closing remarks.
Great, thank you, Carrie. We really hope everybody enjoyed today's SAVi talk, and we hope it was a good use of your time this afternoon, probably evening for some of you. So as you've heard, this talk was organized by San Jose State University's Spatial Analytics and Visualization Center. We call it the SAVi Center for short. And this is our final SAVi talk for the spring semester, but we'll be back in the fall with more talks and other mind-expanding events. So we encourage you to stay in touch with us. And you can do so in 3 ways. You can connect to our department through our Facebook page. You can also connect to us through our LinkedIn page. And you can also join our listserv by sending us an email. And in fact, I'll put in the chat right now links to all 3 of those things. You might want to go ahead and copy and paste those if you're interested. But those are 3 ways that you can stay in touch with us here at the SAVi Center. So to bring us to a close, special thanks to our 2 speakers today and all of our panelists. And I wish everybody a fun weekend.
Thank you very much for having me.
Thank you.
Thank you.
Have a good night.
Good night, everyone.